systems, such as alarms, safety instruments, and pressure relief valves. Critical mitigated barrier systems, such as containers, dikes, gas detectors, water spray, deluges, foam systems, which can reduce the consequences of a loss of integrity. Managing asset integrity begins well before a new process facility is started up and extends throughout the life cycle. The life cycle of any asset follows the 6 phases comprising of design, construction, installation, commissioning, operation, modifications and decommissioning. Structured methodical approaches are taken to identify safety-critical elements. They address each major accident hazard and listed against each of the safety-critical elements associated with that particular hazard. Aging of assets is conceptually represented using the bathtub curve. The shape of the curve reflects the rate of degradation and the effect of accumulated damage on operating margins. The 3 stages are: Stage 1, Initial Stage; Stage 2, Maturity Stage; Stage 3, Aging Stage. Each stage requires a different approach to the inspection, testing, maintenance and modifications. The picture shows a typical bathtub curve. Many companies continue to initiate asset integrity management on a reactive basis, in which issues with equipment and systems are addressed only after they have started to negatively impact the operation. Asset integrity management system is to ensure that a physical asset functions with required integrity performance in terms of functionality, availability, reliability, survivability and interdependence over the required life of the asset. Asset integrity management system is an essential part of the wider process of asset management with a key element of process safety management. Asset integrity management system should be interfaced with other management systems or programs, such as maintenance management system, risk-based inspection and process safety management system. Asset integrity management has been a part of international process safety regulations for many years, including the SABESA directive and its implementations in Europe as well as offshore installation safety case regulations. The SABESA disaster was an industrial accident that occurred on July 10, 1976 in a small chemical manufacturing plant approximately 20 kilometers north of Milan in the Lombardy, Italy. It resulted in the highest known exposure to 2,3,7,8-tetrachlorobenzo-P-dioxin (TCDD) in residential populations, which gave rise to numerous scientific studies and standardized industrial safety regulations. The EU industrial safety regulations are known as the SABESA II directive. In this picture you can see a child victim of SABESA chemical industry explosion. Piper Alpha was an oil platform in the North Sea approximately 120 miles northeast of Aberdeen, Scotland, that was operated by Occidental Petroleum, Caledonia, Limited. It began production in 1976, initially as an oil-only platform but later converted to add gas production. The explosion and resulting oil and gas fires destroyed Piper Alpha on 6 July 1988, killing 167 men, including 2 crewmen of a rescue vessel. 61 workers escaped and survived. 30 bodies were never recovered. The total insured loss was about £1.7 billion, making it one of the costliest man-made catastrophes ever. Piper Alpha Oil and Gas Field Disaster Memorial Emblem. Following major release incidents and casualties in Bhopal, 1984, and additional disasters at chemical facilities and refineries in the USA, the OSHA Process Safety Management Standard became law in 1992. Picture shows Bhopal chemical disaster situation. Since 1992, in the USA, process safety management programs for highly hazardous chemicals has been in place as Occupational Safety and Health Administration, OSHA, as Regulation Number 29 CFR 1910.119. This regulation requires companies to develop and implement program elements to assess risks, maintain information about the process and equipment, properly inspect and maintain equipment, train and qualify process operators and maintenance personnel, and to develop emergency response procedures in the event of a release. In the world of asset integrity management, regulatory compliance is not a one-fits-all process. Many factors shape the requirements of any given company to ensure that the reliability of the plant, pipeline or facility are intact. Human error is a key factor in most major incidents, so reducing the potential for human errors is an essential part of asset integrity management. Inspection, testing, maintenance and modification standards, guidelines and best practices are available as ASME, API, NACE, NFPA, ASCE, IEEE, NEC, etc. to incorporate in asset integrity management. Asset integrity management achievement can be measured by using industry key performance indicator (KPI). Setting KPIs to measure asset integrity management system performance could be as follows: dangerous occurrence, very high potential incident, lost time injury, major injury, hydrocarbon release, failure of SCE, safety critical maintenance backlog and overdue inspection. A typical KPI pyramid shown here. This is the end of today's video. In my next video on this subject, I will talk to you more about asset integrity management. You may send your comments and observations about the content of this video. You may follow us via Facebook, LinkedIn and YouTube by typing Petrosult and Unimark. For receiving our videos on various topics of asset integrity management, you may subscribe our channel. We deliver training courses on various topics of asset integrity management as in-house, public place and online programs. Thank you very much for watching this video.